Thanks. So welcome to my talk. Yeah, I'll be talking about this. A short overview of the talk. First, I'll describe how normal Android applications look like, how they are developed and distributed. Then I'll talk about writing Python applications for Android, how it works, and some related projects that make it easier. And I'll also provide some examples, acknowledgement, and also some of the different projects and sources used for this undertaking, and also some plans for the future. Android, it's a very cut down mobile distribution, which is quite widely used on some 500 million devices already, according to some statistics I've been able to find. It's a Linux distribution, but it's quite unlike to normal desktop distributions like Fedora, Ubuntu, or others, because while it's using the Linux kernel, the user space is a custom job, and it's very incompatible with normal Linux distributions, which complicates porting stuff and making multi-platform Android applications. It has some form of package management, but again, it's cut down and incompatible and doesn't have dependency management, which I will speak about later, which complicates stuff even more. Android applications. There are two types of Android applications, two basic types. The first one are Java-based. They are basically written in Java, but they are using some custom Android classes and interfaces. So they are not very portable. They are running on the so-called Dalvik Java virtual machine. And they were the original Android applications. Originally, there was support only for Java-based applications. Then the NDK applications were introduced. They can be written in C and C++, and they have some slim Java wrapper, which provides access to the application window and to the Java APIs. This is mainly used in games and in applications that need performance, because the Java applications had some performance issues, and it also enables you to some sort of multi-platform reuse, because you can use some libraries, engines, and also stuff like Unity 3D and PhoneGap. They use the NDK interface to support Android, but it's not so straightforward, because again, Android is incompatible in this regard and has a custom C library called Bionic. So stuff that compiles on normal Linux devices, distributions, might not work because there is something missing in this cut down stuff. So the applications are distributed in the so-called APK packages, which is Android package. Again, you can see the Java heritage, because it's very similar to the Java jar format, which is used to distribute Java programs. It's basically a zip file with some added metadata. And normally there you have the Java classes and data and everything in a single package. The packages are distributed through several stores or package repositories. The main one is the Google Play, which is pre-installed on licensed or certified Android devices. And there are many third-party ones, like the F-Droid Free Software Foundation App Store, or Samsung apps and others. Android tries to maintain a binary compatibility. So if you make a package for, let's say, Android 2.1, it should work on Android 4, Android 3, and on all devices. But it mostly works. Sometimes it doesn't. So let's talk about Python and Python application development for Android. Python itself is not present on normal Android devices. It's an embedded platform, so the Android is not using Python like normal Linux distributions do for many things. But there have been some experiments, and it's possible to run Python on Android. But the biggest problem was the user interface. You could just open something like a terminal or connect to your device from your computer and run Python scripts, but there was no support for a graphical interface. That changed in 2011 when the Qt graphics library was ported to Android. And there were also some proof of concepts of running Qt Python applications with Qt Python bindings on Android. But it required quite a lot of expertise and a rooted device. Later, some proof of concepts also for distributing and making the deployment of Python and Android applications easier. So what I've set on about is to combine all these puzzle pieces and to get something that's functional, where you can just write the application entirely in Python. You don't have to modify some Java wrappers and stuff. For the UI, you can use the Qt graphics library, and the application should be easily debugged. You should be able to recompile all the binary components like the Python bindings, the C++ wrapper that starts it all. And also, it should be just a single APK package without needing to root your device to copy something somewhere. Just a package that every Android user is able to install and which could be distributed to the main Google Play application store. So yeah, easy deployment. How it works. It's important to know what the Necessitas project is. It's the original Qt 4 port for Android. They ported the Qt 4 graphics library to work on Android, and it provides all the main important features of the Qt graphics library, mainly the Qt Quick development interface, which enables you to make mobile applications quite easily. It also handles automatic library downloads and updates through the Ministro service. This is important because unlike operating systems that support package management with dependencies, otherwise you would need to bundle all the libraries with your application, but they have a service that you just need to install once as an application on Android, and this service stores all the libraries in a single place and handles updates. So it saves place and makes sure that the libraries are not outdated. So when we have the graphical toolkit, we also need a Python interpreter, because again, it's not there by default. And the situation there is a bit complicated. There are multiple projects supporting Android, because there are some modifications that are needed to compile Android, and I'm not sure, but I think they were not yet mainlined. I've selected the Python for Android provided by the Kiwi project, which is also an interesting project. It's based on the SDL multimedia graphics library and the Pygame bindings for it, and they also support making Android applications. But it's mostly for games because it's quite low level. So when we have the graphics library and the Python interpreter, we also need some interface between these two. So the Python code running on the Android device can communicate with the graphical interface. So I've used the PySide Python Qt bindings, which are quite widely used with even on Windows, and for example, I think in Maya, to write desktop applications, but they can be also compiled for mobile devices. There are classical bindings. They just wrap all the Qt classes and make them available from Python. They needed to be compiled with the Android NDK, which is this native development kit for Android I've mentioned earlier. And they were compiled against the Qt graphics libraries and the Python for Android build. There are some build scripts. I'll just forgot to mention something. On this URL, there are the complete slides, these slides. So if anyone is interested in the links, you just don't have to type them from the screen. You can just open the presentation PDF or ODP document and yeah, click it. There are also some materials to my workshop, which will be at 4 o'clock, and I'll talk about it later. So I'll leave it a bit. So okay, I think that's okay. So I'll go back. And there's another component that is not really necessary, but it provides a better environment for building the graphical user interface. It's the so-called Qt components, because the Qt graphics library has only a very simple graphical primitives in the Qt Quick environment. For example, there is even no button. You have to make a rectangle and attach a mouse area that captures mouse events to it, and then place a label on it. So this, the Qt components provide more high-level interfaces like pages, page stack navigation, buttons, switches, and such elements, progress bars. They can be also compiled with the Android NDK, and you just bundle them with your application, and you can use them. Again, a URL you can visit when you get to the slides. So the package is a standalone package that doesn't need anything else to be manually installed, because it's using the Necessitas Qt libraries. It just needs to install the Ministro application on the first start. Everything is automated. If the user starts such an application for the first time, he is automatically redirected to the Google Play Store to install it. And all subsequent starts are just start the application. So what's in the package? There is the Python code for your application and any QML code if you are using the QML or the Qt Quick environment. Then it contains the Python and PySide bindings compiled for Android, and some Necessitas boilerplate code and a C++ wrapper. The boilerplate code is what handles the redirection to the Google Play Store if the Ministro is not installed. Also, it always checks with Ministro if there are not newer Qt libraries, or if a new application that needs additional libraries is started. It tells Ministro, I need Qt Network, for example, and it downloads it and handles a pass to the application. And optionally, if you want to use them, you can include also the Qt components. They make the application package a bit larger, but again, they make application development quite a lot easier, because it's not so low level like without it. Yeah, a bit of an issue is the application package size, which is about 15 megabytes. This is by default. You can trim it down quite a bit. For example, by trimming the Qt component package or the Qt component theme, if you don't use some of the components. Also, the Python, which is bundled, has all the Python modules. So you can remove modules that you don't use in the application. Also, You can also include the PySide bindings you're using. So it can be trimmed down. And also, because all Python all Android applications need to bundle all of their stuff, this is quite normal for other frameworks like Unity 3D or PhoneGap. They also need to bundle all their libraries. So the only small packages are the ones that use only the Android native stuff. So there are two basic ways to create the package. It's with the Necessitas and Qt creator. You just need a project modified for Python usage, like this example project mentioned here, hosted on GitHub. You just open such a project in the Necessitas and Qt creator and press the run button, and that's it. An APK will be generated, and if you have a device connected, it will be automatically deployed to the device. If no device is connected, it will try to start the emulator and might even start it successfully, because the Android emulator is a bit temperamental. There is another way which is quite nice and faster, and nice from the perspective if you want to automate it. You can also create the packages from the command line by using qmake and and. It's quite complicated, but there are some solutions for it, and I'll talk about them a bit later. So now you have an application package, the Android package, that contains all the needed components for running the application on Android. This was one of the big problems that needed to be solved. But thankfully, one of the projects trying to get Python applications on Android managed to devise a way how to solve this. And it works like this. The APK contains two zip files. One of the zip files contains only libraries that are needed for running the application, like Qt components, Python library, PySide. And the other has only application files. This also simplifies packaging, because when you are not changing the libraries, you just only need to change the zip file that contains your application. So when the application starts for the first time, it acquires all the Qt libraries it might need from the minister of service, and then it unpacks both the zip files to the application folder on the device, and the application is started. There is even a progress bar during this unpacking. So yeah, it's quite seamless for the user, and this is only done on the first start. All subsequent starts are as fast, basically, as normal Android applications, because everything is unpacked, and I think Android is doing some caching, so it works quite fast. Okay. Again. Okay. Just please wait a minute. Okay, so yeah, that's an emergency slide. So basically, this is an Android tablet device, which is showing a an example Python application running on it. So yeah, it looks quite bad on the picture, but yeah, this is it. An application that is written in Python and with a Qt interface on it, and it's running on an Android device. This is a really simple application, but on this picture, this is showing a more complicated and actually a usable application. It's the so-called Miaru. It's a manga and comic book reader written in Python. And on this picture, you can see it's running on again on the Android tablet. It's using the Qt components, the bar and the buttons. And also you can see it can be run on a PC with the Linux distribution. It can be run on the old Nokia, Maemo and MeeGo devices. You can see the N900 and the N9. And also there is the BlackBerry 10 device. That's the right or the left one. So and this is the same application code. It's the same tree. There are no branches. It's the same code that just detects the platform and does some small tweaking. And this code can be easily packaged and run on all these devices. So that's one of the advantages of using Python to write Android applications, because it's not only Python, it's about the application being easily portable to other platforms. Because if you make an Android applications with Java, for example, due to all the custom Android classes, the application can't be easily ported to other platforms. The only solution basically is to emulate the whole Android environment on the device, which is, for example, what the BlackBerry 10 is doing. They support Android applications, but they just emulate a small Android environment on the device. So I'll switch back to the regular presentation. Now, okay. So yeah, it should look like this. I have no idea what. Forget it. Yeah. All these systems. Yeah. Again, this application, there is a link to it. It's using all the components I've mentioned previously that can be used for Android Python applications. So when I was working on this, I also made quite a comprehensive guide for building PySide and Python for Android. This was basically the biggest issue because PySide needed to be compiled with the Android NDK. So that was quite an adventure. So to make the work of others easier, I made a guide and posted it on the Qt project wiki. That was basically what I did. So in the end, you are able to make an APK and install it on basically any Android device. Then came Aaron Richiger, found it nice and made it much more, well, powerful. Basically, it's a project its aim is to make the Python Android application development even easier, to make debugging easier, deployment easier, and make everything faster and stuff like this. So what it does, I'll just go back. So I just mentioned this is basically done by Aaron Richiger. He is from Switzerland. So what Aaron did, the Pydroid project can be easily installed like any normal Python stuff. Yeah, it has a setup Py-based installation. It supports automatic project template generation, because you can do many types of applications with Python, PyCite and Qt. So it has multiple templates you can use to base your application on. Also, as an important feature, it supports renaming your applications, because every Android application needs to have a unique name, a unique organization name, and without this it was quite tedious, because you took the example and needed to change the name in some 5-6 places in different files and formats. And Pydroid makes this quite easy. You just tell it the new name and it finds all these hidden strings and replaces them. The Pydroid can be used both with Qt Creator and command line only tools. So if you just package your application to many platforms, you can easily integrate it with your packaging scripts. It automatically creates these previously mentioned application and library zip bundles. So it just checks if you've changed changed your application or library files, and it automatically repackages them if needed. Also, it modifies the boilerplate. So when the application starts and unpacks for the first time the files on the Android device, it provides a nice progress bar. Previously there was like a black screen for a few seconds and it looked quite bad. It supports the standard Python installation utility, the pip utility, and you can use it to directly add Python modules to the project if you need them. Also, for easier debugging, it redirects the Python standard output to the Android log. Or more exactly, there is a special print function that can be used. So your messages, I think it's not really that important, but it's important because the application, if it doesn't start or has some issues, you can easily check the output from the Android log facility. And I think it even has a prefix, so you can easily filter all the garbage Android is periodically spitting to its log and only get the data you're interested in. Also, it supports fast deployment, because normally you just build an Android package, you have to transfer it to the device, then you have to start it, then you have to let the package unpack all the stuff. But once the package is deployed at least once, it supports the so-called fast deployment, because if the libraries don't change, that's a good thing about Python and QML. Both of them don't need to be compiled. So for the fast deployment, you only transfer basically the text files. So when you change a few lines in Python or QML files, it just pushes these text files to the device, and it can take about 5 seconds between pushing the button or using the command in your computer and the changed application starting on the Android device. It also has Bash autocomplete support and project diagnostics, because there are some conditions that can make problems with everything needs to work fine. So Pydroid also can check if you have your device connected, if it can reach the device, so if the device has the Android debugging enabled and stuff like this, and let you know if something of this is missing. And there is even a very simple Python Android application in Google Play. It was more like a test, if it can really be submitted. So yeah, if you want to try it, you can just go to Google Play on your Android device and search for Pydroid. This is some information about how to install Pydroid. It's more like if you get the slides, so you can try it out. This is an example how Pydroid can create example applications. It's quite clever, so if you just run Pydroid create, it will tell you create example, it will tell you what examples are available. You can also deploy with the Qt creator. The projects that are generated with Pydroid can be opened in Qt creator and started like this. And the log from your application should show up in the normal Qt creator log window. This is the current situation. The current situation is based on Qt in the Qt 4. It's using PySide for binding Python and Qt. And since then there were some new developments. And the biggest one of them is the release of Qt 5. Qt 5 is a big improvement for the Qt graphics library. It brings quite a lot of performance improvements. It's more modular, so you can again make your packages smaller because you can include less of the modules which are smaller because there's more of them. Also, there was an improvement in vector driving support. It has basically the HTML5 canvas integrated. And also the previously mentioned Qt components, which were a separate project from the basic Qt library, have been integrated to Qt. So again, it's something that is part of the library and doesn't need to be bundled. And also the Android support, since Qt 5 is a built-in official part of the Qt graphics library. Previously, the Necessitas project was basically a third-party initiative, but since Qt 5, it's a built-in, officially advertised and tested part of the graphics library. So everything should work better without some kinks that were in the old Necessitas project. Also, you should be able to easily access the Java interfaces in Android and get data from sensors and positioning. So basically it should be faster and you should get a smaller application package. To use Qt 5 from Python, you need some form of bindings. PySide doesn't support it at the moment, so that's out. There is an important and quite an interesting project from the Thomas Perl from Austria. And it provides an asynchronous interface between Python code and the Qt Quick environment in Qt 5, which again enables easy creation of mobile applications. And it's quite an interesting concept, because from the Python code it looks like a Python extension. It can be imported and used from Python code. And from the Qt side, it's just a Qt plugin. So basically, and it also works in quite an interesting way, because it's the Qt graphics library, a Qt context, everything is started, and then the Python code is started. So you can easily do some loading screens and stuff like this. The old PySide-based application took like 5 seconds to start because symbol resolution. This thing starts basically instantly, and you can do anything that takes some time asynchronously. So the GUI will not block, will not be frozen when your Python code is doing something or is importing. And also the result is very small. It's about 100 kilobytes compiled, which is quite smaller than the PySide library. And again, also the code base is much smaller. So all the compilation errors you might get if you just want to compile the vanilla PySide bindings shouldn't happen here. As I've said earlier, the interface is asynchronous. You just basically call stuff from the Qt side. A Python function is called, and it then basically sends something like a message back using the Python extension. And then the Qt side gets a signal, yeah, there is some data from Python, and between these two interactions, it can just do its stuff and doesn't block. Of course, it supports also synchronous calls, but they, of course, block the GUI thread and shouldn't be used if not necessary. There is also support for image loading directly from Python data. So you can do stuff like generate fractals with Python, or forward images stored in database, or extract it as file-like objects from, for example, zip files, which is, for example, what the Miero comic book application does, without needing to unpack them first. There is again a link to the repository, so if you get the slides somewhere, you can check it out. It is being very actively developed currently. The latest change is about a week old. And this is also a possibility. The PyQt 5 project, they recently released the PyQt 5 library, which binds all Qt 5 classes and makes them available for Python. Again, classical bindings, access to all classes, but big size, so if you are bundling it, that's an issue. Also slow startup, because it has to resolve all the function symbols and startup. And again, it's a lot of code, not really made for cross-compiling, so that might be an issue. But the authors mentioned that because Qt 5 officially supports Android, they want to add it too, so this might be an alternative in the near future. Again, this is basically a link page for all the projects for anyone interested. It lists basically the authors of the various puzzle pieces I've been using to get it all together. And yeah, shows also how I get there. And that's all from my talk, and I would like to ask you if you have any questions.
Thank you, Martin.
Do you know how many, or if there are any applications in the App Store that are using this? Are there any production applications that are already using it?
I don't really know about any. There were some questions from users. There were some emails to the Pydroid project. It's quite it was developed in the last few months, so it's quite an early thing. Also, I was quite busy recently, I think, and Aaron Richiger also was quite busy. So it was not really publicly announced anywhere, because there are still some drawbacks. Like we haven't yet figured out how to access the complete Java API, the intent stuff, some specialized sensor stuff, positioning. So it's more like it works. You can do Python applications that can do quite a lot of stuff, but I think it needs some small changes, small improvements before it can be really like publicly announced. Like, yeah, this is the definitive way of doing applications for Android. Also, with the Qt 5, I feel it might be also good to work on this, because it should enable to make it even more streamlined, smaller packages, faster startup. But it's all there, so if anyone wants to use it in this form or to contribute to improve it, I think it's on a good way.
Okay, I have a few questions. First one, you mentioned about Ministro. What is it exactly? Is it extra app in App Store downloaded, or maybe it's some place in with site where all necessary libraries are downloaded? How does it work?
So Ministro, basically it works around the problem with Android packages that they can't have cross-package dependencies. It's from the outside, it's basically an Android application, and it was developed by the Necessitas project to handle Qt libraries, and it uses the cross-application communication interface in Android, and basically it does if any Qt application is started and Ministro is not installed, the user is basically sent to the App Store to the Ministro page, and he needs to install the Ministro application. Once the Ministro application is installed, any Qt application that starts notifies Ministro, I am a Qt application, I need Qt base, I need Qt network and Qt XML. Ministro checks his storage space, if these libraries are available or if there are any updates. And if any of these libraries is not there, it will download it from external repositories from the internet. And once done, notifies the application, the libraries are there, load them from here. Because the applications, while can't have any official dependencies, they can look at each other's data. So the Qt applications just load the library files from the Ministro application storage space. Also, recently there was a support added to custom repositories. So theoretically, one further improvement would be you could host the Python libraries, the PySite libraries, basically any big data could be hosted in a custom Ministro repository to make it smaller, the package.
How big amount of work is needed to do some migration ports between, for instance, Ubuntu and Android? Because you show us application which run on few different devices. How big amount of work is needed to do something like this?
Basically, if the application is, it shouldn't be that difficult, because if it's just an application that's using, of course, the problem is you need to bundle all modules you are using. So external modules need to be included in the application package. This can be also done by the Pydroid library, by the Python easy install utility. But when the application, if it doesn't have any really special demands on stuff only available on desktop, it should work quite fine, because it just it doesn't really know it's running on Android. So a normal application that's sets up a window, adds some widgets, or sets up a QML context, adds some stuff to it, should work quite fine.
And last question, I'm interested about default. For instance, Android has some default buttons and widgets, and Qt has own buttons. So is it possible to use default Android templates or something like this to render application, or should we use only Qt buttons?
Basically, in this combination of components, it's completely independent on the Android widgets stuff. It just acquires an Android window and does all its rendering. I've read about some other possible ways of making Android applications, and there should be some way how you can set up the Android forms. But I'm not really sure how it works. But I've heard something like this should be possible. Also, you can also style it to look like Android application. And I'm not really sure, but at least in the Qt 5, the Qt Quick controls, which is the new Qt components, I think they're working on styling them to work and look like quite like on Android. They should look like Android. On Tizen, they should look like Tizen. On desktop, they should look like something else. So that might be also another thing that might be solved in using Qt 5 for it.
Okay, thank you.
So I have a questions actually. So one question is similar to the the touchscreen devices really took off when the developers learned that these are not things like desktop machines. And Windows C, for example, in the past worked mostly like a Windows system. But when they learned about limiting the amount of widgets on the screen and things like pinch to zoom and stuff like that, that's when it really became usable. So when you have a single application that you port from a PC to for example, phone, how does it handle the different way that we use the the device?
So basically, this depends on how the graphical user interface is designed. This thing, of course, would not somehow automatically transform the user interface. It's more about both making a mobile applications with a mobile application interface with kinetic scrolling, big buttons, and just something that you can easily use on a mobile device, and being able to both run it on multiple mobile devices without having to make ports or forking it or making a native application for 5 platforms. And also it enables you to have a single Python code base that has different user interfaces. One for a desktop, one for tablets, for example, one for smartphones, something like this, with a common Python core that can easily run on all these devices with different interfaces for a specific device.
Okay, so is the Qt application, for example, on Android, as convenient to use as native Android applications?
It supports all the user interface primitives that Android applications have. It has kinetic scrolling lists. It supports multi-touch, pinch gesture to zoom. Basically, you can do the same with like Android applications can do.
Okay, and do you know about any efforts to actually, because we have some techniques for accessing Java objects from Python, so do you know of any solutions that use this method to actually build the UI using normal Android libraries and just interface them to Python callbacks?
It should be, I've mentioned it should be somehow possible. I didn't concentrate on this because I already ported some of my applications with the Qt UI, so I didn't really investigate this, but it should be possible. It is related to the stuff that's still work in progress, and that's using the Android, the Java native interface on Android. So to get to the intents, to launching different applications, and also to get the sensor data and other Android APIs. So if this works, it should be theoretically possible also to construct just some Java activities like for normal Android applications from Python, because it's all Java API. So this should be possible somehow.
It could be cool. Thanks.
Okay, so if I want to write some commercial application right now, will you recommend this technology, I mean Python and Qt for Android, to use it or not now? Not yet.
I would say it's possible to use it. It's also the license for it is commercially compatible, because the PySide bindings are LGPL. The Qt library is also LGPL. So yeah, it's possible to do it. I'm not saying this is, it depends. If you want to have some application that's multi-platform and written in Python, this is a way to do it.
Okay, thank you.
Okay, thank you, Martin. The next talk here will be in 10 minutes, and it will be about Python and Microsoft. So
I'll just mention there will be a workshop at 4 o'clock. So if you are interested in the workshop and you are going to come here, it would be good if you can, in the meantime, install the Necessitas NDK, also the Pydroid project. What?
you have it on a pen drive, or can you?
I'm not sure it's really possible, because they only have an online installer. So the online installer fetches stuff from some KDE repos, but I'll see what I can do if I can somehow get it to a pen drive. Also, I'm working on basically something like a launcher that just has all the dependencies built in, can be installed on any Android device, and just launches your Python and QML files from the SD card. So if for people who don't have the NDK, they can easily try running Python applications on Android just by editing a few files, adding more files and stuff like this. So this should be handled somehow.
Okay, thank you very much.